Oh, okay, boys. We're skipping 3, 4, just in case anyone realizes, hey, wait a second, what happened to 3, 4? Don't worry about 3, 4. You're not going to see them in the SAT or the ACT, and it's not as important as the book dictates it is. But this is very important, okay? We were talking so far, we're learning how to work with systems of inequalities and of equations, but when you have two variables, x and y, nice and easy. Today we're going to be learning how to work with three variables, okay? You can use the elimination and substitution methods to solve a system of three equations in three variables by working with the equations in pairs. I'm going to show you what that means in a second. You will use one of the equations twice. When one point represents the solution of a system of equations in three variables, write it as an ordered triple. We already know what ordered pairs are, but an ordered triple, again, is in alphabetical order, and it's going to be the x, y, and z, okay? Just in case you want to know what that looks like, okay? You have your x and your y-axis here, okay? But z, it comes out 3D. Now, I know this is linear, so it's kind of hard to see the three dimensions, but that dashed line, that's the third dimension. That's what gives us depth. Whenever you guys watch the 3D TVs, 3D movies, or any 3D anything, video games or movies, you're having three dimensions because you have the linear dimensions of up and down, and then you have the dimension of depth. It comes out. It's kind of like for volume, length, width, and height, there's three dimensions. So that's what three-dimensional really is. Okay? We're not going to have to worry about graphing it yet. You guys will have fun doing that in pre-calculus. Now, let's just get to it, okay? Doing this, the only way to do this is to just knock it out. I think I set it up in a way where it should be nice and easy for you guys. So let's see if I did a good job. We want to solve the system 2x minus y plus z equals 4, and x plus 3y equals z minus z equals 11, and 4x plus y minus z equals 14. Okay, first thing you're going to do, pair the equations of the system to eliminate one variable. Now you have an equation with two variables. Okay, you can pair any which ones that you want, okay? You could select these two, you could select these two, you could select these two. Doesn't matter. I like to keep things simple, okay? So unless it's obvious that I have to choose something else, which we'll see some examples of what that is now in a little bit, I always start with the first two, okay? So I take the first two and I set up my system right there. That's A. So let's go ahead and do this. Excuse me. Using the skills that we know of elimination, what can we eliminate right off the bat here? What's the nice, easy, pretty thing to eliminate? Denny. Thank you. Thank you. Okay, so this goes z, and I've got 3x plus 2y equals 15. Is everyone with me so far? I chose the first two. I eliminated any variable I want. Did I have to eliminate z here? No. I could have eliminated x or y. So, Mr. Morrow, why did you choose to eliminate z? In this particular case, it just did the job for me. Does that make sense, guys? Because z minus z, they just cancel out. Now, in the other one, the next one here, hey, not so easy, but still easy. Now, here is where you are forced. Your hand is forced, once you choose to eliminate any variable you want in this first pair up right here, once you choose a variable that you're going to eliminate, you have to eliminate that same variable here. So even if I had an x and a minus x here, the temptation is to cancel the x's, right? No, cannot do that. So that's the only thing about this. Once you choose on part A who you're going to eliminate, your hand is forced to eliminate that same variable in the next pair. And the next pair, of course, were these two. Does that make sense so far before I move on, gentlemen? Yes, sir. Since I eliminated z here, I'm going to eliminate z here. Yes. Yes, you chose these two. Now you have to choose these two. Okay. The question was, can you first choose this guy and this guy? No. No, okay? That's why, okay, I love repeating myself, so thank you. I appreciate it. You can choose these two, then these two, or these two, then these two, or any other combination. There's many combinations. But that, like I said, is going to lead to confusions later on. So what I like to train my students to do, unless there's a special case, which we will get to, you choose the first two first. That's A. Then you're going to choose the second and the third, and that's B. Don't make your own rhythm here. Don't think you're going to do it better. Please follow directions. If I say up, don't go down, go up. If I say this, don't do that, do this. If I say that, don't do this, do that. This is very complicated and confusing if you don't follow directions. May I continue, sir? Thank you, sir. Does anyone else want me to repeat anything? Because I do not want to repeat myself again. Gentlemen? Thank you, gentlemen. Okay, so here, I have to eliminate z. There's no choice. So I'm going to multiply this guy by -1, giving me a negative x minus 3y plus z equals -11. When I combine them, I'm going to get 3x minus 2y. The z's cancel. And then I have -11 plus 14 is 3. So -3 or +3? Yeah, +3. So this down here is a typo. Okay. Is everyone with me so far? Okay, we eliminated the same variable for the first two and for the second and the third. And now I have two equations that have just two variables. Step 2, write the two equations as a system. Solve for the two variables. In this case, it worked out really, really pretty. Oh, and that's why I did that negative. Mr. Morrow. I thought I had made a mistake, but I did not make a mistake. I was correct. All right. I just skipped ahead a little bit. This guy is this right here, right? And this guy is this guy down here, but I multiplied everything times a -1. Why did I do that? Because I want to cancel out the x's, right? So I got 4y now equals 12. So y equals 3. Now that y is 3, okay, I plug in the known variable values into one of the original equations and solve for the remaining ones. If y equals 3, I can plug it back into this. 3x plus 6 equals 15. 3x equals 9 divided by 3. X equals 3 as well. Now that I have x and y, I can go back to any of the original equations, plug in my x and y, and find z. So for this particular case, I'm just going to choose this bottom one. 4 times x, which is 3, plus y, which is 3, minus z equals 14. This is 12 plus 3 is 15, minus z equals 14. Subtract 15 to both sides. Negative z equals -1 divided by -1. z equals 1. My solution is x, which is x, comma y, which is 3, comma z, which is 1. You had a question, sir. Thank you. Yes, sir. Yes, sir. Part 2, yes. Yes, sir. Because I wanted to eliminate the x's nice and easy. I could have started by eliminating the y first. Either way. Yeah, either way. Either way. I chose to do the x's. You could have done the y's first. Does that make sense, gentlemen? So it's not too bad, really. Choose the first two and solve, okay, and eliminate one variable. I don't care what variable. Then take the second one and the third one and eliminate the same variable. Now you're left with two systems with two variables. You solve those by either substitution or elimination, which is what we've just learned. You're going to find one of the variables, plug it back in, find the second variable. Then you plug in the two variables that you know into either of these original equations, and you find your last C. Does that make sense? The good news is that's it. We're just going to do this over and over, okay? I'm just going to show you some different techniques and just different ways to help you out. But this is it in a nutshell, okay? May I continue, guys? Before I move on, I want to make sure that at least you understand the crux of this, you know, the main part of this. You understand the procedure? Okay, thank you. Okay, now, no steps, okay? No steps. Let's just do it together. All right, but I'm going to follow directions, and it's not going to be so difficult. I'm going to take first two, okay? Call that 1 if you want. So over here, we got x minus y plus z equals -1, and x plus y plus 3z equals -3. To me, it's a no-brainer who we're going to eliminate, but I don't care what's easy for me. I want to make sure you see it. So I'm not even going to mention what I would do. What do you want to do? Oh, all these hands, great. Yes, sir. Yeah, you want to get rid of the y. Absolutely. Boom. I got 2x plus 4z equals -4. Is everyone with me so far? Okay, that's one of our major players right now. Now, our second setup equation that we're going to do is this guy, right? So you've got x plus y plus 3z equals -3, and you've got 2x minus y plus 2z equals 0. Of course, it's working out nice and pretty in this case, and the y's automatically cancel out nice and easy. So I've got 3x plus 5z equals -3. Is everyone with me so far? I took the first two equations, eliminated a variable. I took the second and the third equation, eliminated the same variable. Now I'm left with two equations. I'm left with one system with two variables. Does that make sense so far? Okay? Because I'm going to scroll up. Are you guys sure? Hold on. Let's see if I could rearrange this. See if I could do something fancy here. Let's see. Okay. Now, next step. Step 3. We're going to take these two equations, right, and combine them, right, and solve for x and y. So I got 2x plus 4z equals, come on, Moro, equals -4. Come on, man. And then I got 3x plus 5z equals -3, yeah? Okay, this one isn't so simple, but it's okay. What do you want to solve for? That's the key. X, okay, someone chose x. Could you have chosen z? Do I care? No. Will any teacher care? Will any test or SAT care? No, doesn't matter. But you guys said x, so we're going to stay with what you said. Okay, my brothers, what do I got to multiply to get rid of these x's? Okay, if you want to do 3 to the top, that's fine. And then to the bottom, you have to do -2. Okay, because remember, we need them opposites. So this is 6x plus 12z equals negative 12 minus 6x minus 10z equals 6. Boom, cancels out. 2z equals negative 6. Z equals negative 3. Okay, if you want, you could like put that over here on the side just to, you know, keep a little log. Now that z is negative 3, I'm going to plug it into either one of these original equations. So I've got 2x plus a negative 12 equals a negative 4. Add the 12 to both sides. 2x equals 8 divided by 2. No, because that's a negative 4. No, my bad. It's just very tiny. Sorry, kid. Sorry to cause confusion there. 12 minus 4 is 8. 8 divided by 2 is 4. So I'm going to put that bad boy over here as well. And now I'm just going to plug it into the easiest original equation, which in this case is this. So I've got 4 minus y plus a negative 3 equals negative 1. 4 minus 3 is 1. Subtract the 1 to both sides. So negative y equals negative 2 divided by negative 1. Y equals 2. So y equals 2. So my solution is x, y, z. Can I test this, Mr. Moore? It's a lot of work. Can I test it? Heck yeah. 4, right? 4 minus 2 is 2, right? Minus 3 is negative 1. It works. 4 plus 2 is 6. Minus 9 is negative 3. It works. 2 times 4 is 8. Minus 2 is 6. 6 minus 6 is 0. It works. Talk to me, boys. Sir.
When you're picking the first two to do the first step, does it matter which two you do? Or...
The question was, does it matter which 2 you use to begin with? Yes, this is the 3rd time now that I have repeated this. You are always going to choose the first 2 equations. Unless there's a special situation, which we will go over. But yes, you choose equation 1 and 2, and then equations 2 and 3. Does that make sense, gentlemen? Okay. Now, okay, check it out. Now, in this case, we got to use substitution. Sometimes you can use substitution to solve a system of 3 equations. This method is used when you can easily solve one of the equations for a single variable. You're not going to do this very often, guys, okay? This is only going to happen. Please be paying attention, because I don't want to repeat this 3 times as well. You only do substitution when you can easily solve any of the given equations for one variable. So when I look at this, I immediately find an equation that's really easy to solve for one variable. That's exactly right, buddy. That would be this one. So I hear for number 1, choose an equation which can be solved easily for one variable and solve that variable in terms of the other. So in this particular situation, x equals negative 5y plus 9. Okay? You guys with me so far? Now, since I'm replacing the x, okay, and I already used this, I already know that this guy right here is x equals negative 5y plus 9. This is one of those special cases where you do not use the first 2. In this particular case, you're going to use the first one and the last one, gentlemen. That's where you have here step 2. Substitute the expression for the variable you solve for into the 2 remaining given equations. So I'm going to have 2 times x, which is
5 minus 5 plus 9.
Thank you. Negative 5y plus 9 plus 3y minus 2z equals negative 1. When I combine this, that's going to be negative 10y plus 18 plus 3y minus 2z equals negative 1. So in total, this is going to be negative 7y minus 2z. I'm going to subtract the 18 equals negative 19. On this guy over here, I've got 4z minus 5 times x, which equals negative 5y plus 9 equals 4. 4z plus 25y minus 45 equals 4. And then I have 25y plus 4z equals positive 49. So everyone see what I just did there? You promise, guys. Take a look at it, absorb it, love it. Make sense? Okay. Now, step 3. Write the two new equations as a system and solve for both variables. Okay. Who's going to be easiest to solve for here? This is the y or the z? Heck yeah, the z. You could have done the y, but I wouldn't have. That's exactly right. Great job, my brother. 14y minus 4z equals negative 38. 25y plus 4z equals 49. So that's going to be 11y. That's equals 11. So y equals 1. Now that y equals 1, plug it back in here, guys. So 25 times 1 plus 4z equals 49. Subtract the 24. So 4z equals 24. Divide by 4. Z equals 6. Give me pause for the announcements. All right. Sorry about that little interruption. Okay. So far we have that z is 6 and y is 1. So now we plug it back into here, into any of them to find x. But since we already know that y is 1, do we have to plug it into the complicated ones? No, man, I plug it right into here. X equals negative 5 times 1 plus 9. So x equals 4. So my solution is 4x, y for 1 for y, and 6 for z. In a nice, this is not called an ordered pair, it's called an ordered triple. Yes? No. Unfortunately, the other way would not work here. Because what's going to happen here, my man? When you go to get rid of a variable, what's going to happen? You get rid of the x, but then you have a y and a z, and then just a y. And then here, you just have a z and an x. So, unfortunately, that's why I taught it to you. No, if you could do it the same way over and over, I wouldn't have taught this to you. Okay, let's give an example here right quick. Okay, which one here is very simple to solve for one variable? Yes, sir.
Please pardon this interruption. Just to verify, go over tomorrow, 10:26.
I'm sorry.
Tomorrow, Wednesday.
Okay, sorry about that. Okay, so here, I'm going to use this guy. And me personally, I'm just going to solve for x. So x equals 2y minus z minus 4. Is everyone with me there? Yeah? Yes? Okay, now, let's plug this x, okay, into this guy here. Or actually, you know what? Why am I going to make my life miserable? You don't have to do substitution unless you have to. How about that? I'm going to go with what my boy said. Let's not do it just to do it. Let's do it when it's appropriate. So in this case, let's take our first two. Okay, and I've got x minus 2y plus z equals negative 4, and negative 4x plus y minus 2z equals 1. Notice how I make my z's. Okay. Me personally, I'm going to get rid of the y's. So I'm going to multiply the bottom here by 2. So I'm going to have x minus 2y plus z equals negative 4. And I'm going to have negative 8x plus 2y minus 2z equals 2. Guys, I know we're going to be cutting it close. I know you want to pack up. I know you want to leave. I know you want to ignore me. I'm asking you nicely from the bottom of my heart to please just give me a couple minutes. Please. Yes? Ah, okay, thank you. So, okay, so minus 4z. Okay, so here the y's cancel, and I'm going to have negative 7x minus 3z equals negative 2. Now I'm going to take these two guys, okay, to save time, because I know you guys want to get out of here. I have to this time. I have to get rid of the y. So actually, I'm not going to multiply that by anything. I'm going to multiply this guy by a negative 2, giving me a positive 8x minus 2y plus 4z equals negative 2. The y's cancel, so I'm now going to have 10x plus 3z equals negative 2. Look at the way life works out sometimes. Now we're going to have to solve for x and z. The z's cancel right off the bat. 3x equals negative 4. It's not going to be pretty always. X will be negative 4/3. Okay? I want to make sure that is right. But yes, it is. Unfortunately, that's just going to be a little bit ugly. All right? But that is correct. Are you with me so far? Yes, guys? Okay. So that is what my x is. Now I can plug in my x into either of these two original equations to find z. So I'm going to have, let's say, let's do this one. 10 times negative 4/3 plus 3z equals negative 2. So this is going to be negative 40/3 plus 3z equals negative 2. I'm going to add 40/3 to both sides. 3z will equal, that goes to 3, that goes to negative 6. That's going to be 34/3. 34/3 divided by 3, so you multiply by the reciprocal. So z is going to equal 34/9. Okay? So I have my x, I have my z, and now I plug it in to find my y. Is everyone with me so far? Okay? So I'd have negative 4/3 minus 2 times y plus z, which is 34/9 equals negative 4. A lot of nasty math here. This becomes a negative 12/9. Okay, so I have negative 2y, negative 12/9 plus 34/9 is 22/9. All right, so plus 22/9 equals negative 4. Subtract 22/9 to both sides. Negative 2y is going to equal, that goes to 9. That goes to negative 36. So that's going to be negative 58/9. Almost done. But then divide by negative 2. So times the negative 1/2. And I'm going to have y equals 29/9. So my solution would be negative 4/3, 29/9, and 34/9. My goal is not to give crazy numbers like this. But sometimes things happen, and you're going to get crazy answers. That's why it's really important for you to check your answers in the back of the book. Thank you for your patience. May God bless you all. Have a good day.